Okay, in this video, let's talk about one of the most controversial topics in math. Why is 0 to the 0th power undefined? First of all, disclaimer, this video has nothing to do with calculus. So do not leave comments regarding to limits whatsoever. We are not going to do any limits at all in this video. This is just meant to be an innocent, well actually not innocent, it's rather evil. Anyway, 0 to the 0 like an algebra question. This is just purely computational. It has nothing to do with calculus. I will do the 0 to a 0 indeterminate form for limits next time, not today, okay? So seriously, do not, but you know what? When I say this, people are still going to comment down below with limits whatsoever. This is YouTube, I understand, so up to you guys, whatever. Anyway, first of all, it's a good idea to review the exponents definition. So let's take a look of 2 to the 3rd power. Of course, as we all know, when we have a positive whole number for the exponent, for example, this 3, it will tell us to write down this 2 3 times and then multiply them together. So you see, we have 3 2's right here. And once you have this, go ahead and work it out. Of course, we get 8. And this is nice when we have positive exponent, right? Positive whole number for that. But we are going to run into trouble with this little definition when the exponent is not positive whole number anymore. For example, when we have 2 to the 0th power, as you can see, this right here, it wouldn't make sense for us to write down 2 0 times. What does that mean? I'll just put down equal to empty space. Kind of cool. And this is how you can do math. You see, if you just leave nothing here on the test, you get like 100%. How cool is that, right? Of course, this wouldn't make sense. Now, let's see. How can we define the 0th exponent for this situation? To do so, maybe we should follow a pattern. Let's look at the next one, which is 2 to the 2nd power. In this case, of course, we write down the 2 times, so it's 2 times 2. Of course, this is going to give us 4. And then, of course, we can keep on going. Let's look at 2 to the 1st power. This right here still makes sense. We can write down the 2 one time, and the answer is just by itself is 2. And as you can see, I'm following this pattern, 3, 2, 1, 0. But on the right-hand side, I have 8, 4, 2. So what's the pattern on the right-hand side? Of course, from here to here, we divide it by 2, and from here to here, we divide it by 2 as well. And wouldn't it be nice if we can keep the same pattern on the right-hand side by dividing by 2? If so, 2 divided by 2 will be 1, and as you can see, to make sense of the 0th exponent, the best definition is just to make it equal to 1. And this right here, as I mentioned it, it's a definition. This right here is not a proof at all. In fact, the 0th exponent, you cannot say, I'm going to prove the 0th exponent is 1. No, it's a definition. Because you have to first give a meaning to the 0th exponent before you can do anything else, right? So don't call this a theorem statement whatsoever. This is just a definition. And by showing you guys this, I know some people are going to debate in the comment sections already. Up to you, it's YouTube, I understand. In fact, if you follow this, I can give you guys another definition because we can go to a negative exponent. For example, if I keep on going, I will end up with 2 to the negative 1 power. And of course, this right here, it wouldn't make sense at all, again, to write down 2 negative 1 time. How can you even do that, right? Well, to define what this is, of course, let's follow the pattern on the right-hand side. And divide this by 2. 1 divided by 2, of course, that will give us 1/2. So perhaps the best definition is to define 2 to the negative 1 power to be 1/2. And once again, this right here is just a definition when you have negative whole number power, right? So once again, this is just another definition. And in fact, you can keep on going. For example, 2 to the negative 2 power, you define that to be 1/4 because you have to divide it by 2 again on the right-hand side. And you do this so that you can actually graph 2 to the x as a continuous function, which is really nice. All right, so that was just a nice review. Now, let's get into the main dish today, which is 0 to the 0th power. And to do so, I'm going to consider this equation first, namely y is equal to x to the 0th power. Let's talk about the graph of this right here real quick. For example, as we all know already, when we have 2 to the base, when we have 2 for the base, and then raise that to a 0th power, we get 1. So that means for this equation, if x is 2 right here, the y value should be 1. So we have this point here. That's nice. And similarly, if you have 3 right here, of course, to the 0th power should be 1 as well. You can follow the similar thing. So we can also have 3 here and then 1. And likewise, we can put down, let's say, 0.5 and then to the 0th power, that should give us 1 as well. That's very nice. Maybe we can also work with negative number. If I have negative 1 right here for the base, to the 0th power, in fact, you can also work this out right here, and you'll still end up with 1. So I will just give you guys this right here, negative 1 for x, and then the y value is 1. And of course, right here, we have a bunch of dots already. Why don't we just connect the dots? And everybody is on the horizontal line, right? So it seems like I should just connect the dots like this. Everybody is equal to 1. That's nice. So based on this, it seems like when x is 0, the y value should also be 1 as well, isn't it? So let me just indicate that right here. Seems like when x is 0, okay, I'm putting 0 for x, and then 0 for the power. It seems like 0 to the 0th power should be 1. But have you ever thought about what if the base is 0 instead? So let's take a look right here. Let's go ahead and consider another equation which is really similar when you have 0 to the x power. When x is 2, we are talking about 0 squared. Well, that's going to be 0. That's nice. So you have a 0 right here, right? Y value 0. And likewise, when x is 3, the y value 0 to the 3rd power is 0. Likewise, 0.5 right here. That's 0 to the 0.5 power. That's actually the square root, as I mentioned earlier. You get 0, and you have this right here, right? So it seems that everybody should be just on 0. But if x is negative 1, when you put negative 1 right here, you get 0 to the negative 1 power, and by this, you see this right here should be 1 over 0, and this right here is undefined. Hopefully by now, we don't need to have a little topic discussion like why 0 in the denominator is undefined, so I'll just give you guys a sad face. And this right here is actually true for all negative number for x in this case. In fact, we don't have the left-hand side at all. So it seems that we just have the right-hand side, which is just like this, all right? Like that. And now, based on this picture, if x is 0, when you put it here, what does it seem like? Well, I have the 0 for the base. If I put x equals 0 in here, in pink, it seems like I should have make this equal to 0 in order to make this continuous. Likewise that. And as you can see, of course, the colors right here, the 0 to a 0 versus this 0 to a 0, they are the same. But we end up with 2 different answers. And that's troublesome, of course. We don't like that in math. So the conclusion is that, let me just cross this out. No, let's just don't deal with this at all. Conclusion, which is the one that we have over there. When you see 0 to the 0th power, to avoid any kind of this kind of contradictions whatsoever, this right here is undefined. If you want, you can also say undefined. That was a joke, but anyway. Okay, now if you want to have more questions to practice with, then I would highly recommend you guys to come to Brilliant.work. Especially check out their new daily problems, and here I have a geometry question for you guys. Take a look right here. Suppose you have 2 equal volume cylinders, and you put a cone here and you put a semi-sphere here. And the question today is, which of this area is bigger, the orange one or the green one? And again, you can come here and check this out on your own. And if you guys like this kind of questions, be sure you guys come to the left hand side so you guys can go check out the quiz right here. And I'll also show you guys another question right here. And for this one, we have to calculate 2 to the 1000th power minus 2 to the 999th power minus ... minus 2 to the 0th power. And again, you have to choose the answer right here. And if you want more of these questions, you can also check out the quizzes. So I think you guys will really like this format of questions, especially it takes about 5 minutes to solve and learn new things. And if you want to study more, you guys can check out their courses, and you can also use the link brilliant.work/blackpenredpen, so this way you can get a 20% off discount for the annual premium subscription. Hopefully you guys all like this. Leave a comment down below and let me know what you guys think. And if you guys are new to the channel, be sure to subscribe. Thank you guys so much, and as always, that's it.